Let's focus in here. Identify, so we're solving. We're doing more solving and that we did yesterday. If not, even them out. Now, we're doing more solving like we did on Friday. And so we're starting out with this one here. X is equal to the square root of x plus 6. All right. Okay. It should show up. It should show up eventually. Yeah. Now, well, we'll look at this here, this problem here. So we want to solve x is equal to the square root of x plus 6. So the first thing, even though we do have variables outside the radical, the steps still hold true. Is there one radical? Well, yes. If so, get it by itself. Is the radical by itself? Yeah. So we want to put both sides to the nth power. What power are we going to put both sides to? 2. Now the right-hand side is kind of nice because the radical and power simplify, leaving us with x plus 6. The left-hand side, we have x and it's being squared, and it will become x squared. Questions on this so far? So, we've done step 2. Step 3, any radicals left? No. So we can move on to step 4 and solve. Since we have an x squared term, we need to get this equal to 0. So what can we do first? So we can do either one. We can minus x squared. That's perfectly fine. Which shows us 0 is equal to now we just need to solve for x, yes? So we can factor it, we can use the quadratic formula, or we could graph it, yes. So we have negative x squared plus x plus 6. Graph. And we have this here. Now we have 2 places where it crosses the x-axis. And those 2 places are negative 2 and 3. So we're saying that x is equal to negative 2 and x is equal to 3. Questions? Y equals negative x squared plus x plus 6. Now, it's going to be good to check. Let's go on and check these here. So we'll start with 3. And we're going to replace x, every x, with 3. Now, the left-hand side is kind of nice to check. Mainly because, well, apparently it's decided not to scroll. That's fine. It's just 3. Now, the other side, inside the radical, we have 3 plus 6, which is 9. Square root of 9 is 3. So that works out nicely that 3 is indeed equal to 3. Let's check the other side. Other number, negative 2 is equal to negative 2 plus 6. Well, the left-hand side, we would have negative 2. Inside the radical, negative 2 plus 6 is 4. And the square root of 4 is 2. So is negative 2 equal to 2? No. So x equals negative 2 is not one of our solutions. So the only solution that worked that we got was x is equal to 3. Negative 2 is a extraneous solution, and we get that because of our squaring the x. Because negative 2 doesn't work, but when we square it, we get 4, and it offsets that negative. Negative 2 is a solution we do get from solving, but does not work in the original context. Questions on this here? We're ready to see another one. The next one we're looking at, x is equal to the square root of 20 minus x. There is indeed one radical, so we need to get it by itself. Well, it already is by itself, yes? So we need to put both sides to the nth power. What power are we putting both sides to? 2. Now the left-hand side, just like the last one, is x squared. The right-hand side, the square root and square would cancel, giving us 20 minus x. All right. So that takes care of steps 1 and 2. Step 3, are there any radicals left? Well, no. Step 4, solve. What can we do first? We can minus x squared. Since we're going to end up graphing these, the fact that the number in front of x squared is negative really doesn't make a difference. We're still going to get the same answers. Because again, I have a feeling we want to graph this, yes? Y equals. We have negative x squared minus x plus 20. Now, if we'd gone it the other way and moved everything to the x squared side, we would have gotten x squared plus x minus 20. I'm going to graph it. Well, for the most part, everything about the graphs is completely different. Second graph, if we look at the table, what are our two solutions? Four and negative 5, yes? Because again, we're looking for what values of x make the y value be 0, yes? Is it the same 0 for both of them? Because at negative 5, the y value is 0 in both cases, yes? At 4, the y value is 0. Are the rest of the values the same? No, they're actually, if you notice, they're mirror images of each other. Negative 10, 10. Flipped. Everything else changed, but our solutions are still the same. It's still telling us that x is 5 and x is 4. So these are two solutions. Since we're graphing, it really doesn't matter if the x squared is positive or negative. We just need it equal to 0. Any questions on this here? How do we feel about these? We're good with these here? All right. I got a feeling we don't need to see another one of these. Do we? No, because most of it at that point is solving. Let's look at this one here. All right. Is there one radical? Yeah. Yes. If so, get it by itself. Is it by itself? No. So what do we need to do first? Minus 13. 13 minus 13 is 0, telling us the square root of 5n is equal to negative 10. Yes. We can put both sides to the nth power. And our nth power in this case is 2. Now the square root of 5n squared is 5n, because our square root and square cancel, yes? Negative 10 squared is 100. Okay, we don't have any radicals, so step 3 is still moot. Moot, not mute, moot. And then we would do what? Solve by dividing both sides by 5, telling us n is equal to 20. All right. Before we move on, let's check it, just make sure it works. Now the right-hand side is 3. I actually can't remember if I checked the last one, but we can go back and look. Now the nice thing with this side here, 13 plus 5 times square root of 5 times 20, is I don't have to do this by hand. plus second square root of 5 times 20. We could type the whole thing in and get 3, yes? We got 23. Well, is 23 equal to 3? So what does it tell us about 20? It's wrong, which means this is no solution. Okay. Before we move forward, I'm going to go back. What did we say about a square root? The numbers that come out of a square root have to be what? Positive. Yes? So is there any way that the square root of 5n could ever be negative 10? No. So this is no solution. If we notice that we got the square root by itself, and not just square root, even root, because there's not an even root that will give us a negative number, we can say no solution. Even if we don't see that, we can still find a solution. We did, but when we checked it, it would give us a no solution. And that's what I thought. We never did check this one here. Getting ahead of myself. If you were to guess, which one doesn't work? Negative 5. It's not always going to be the case that the negative doesn't work. But if we look at this here, we have x by itself, yes? Is there anything that's going to reset or fix that negative? Well, no. Because on the outside we have negative 5, yes? Is equal to a radical. Well, again, as we just saw, the number that comes out of a radical cannot be negative. And it works out, if we plug that in, we get positive 5. Well, 5 is not equal to negative 5, so that's not true. And the other one would tell us that 4 is equal to 4. So x is equal to 4 is our only solution here. Questions on this here? Good with this here so far. Now the main case or main areas that we know we'll need to check our solutions is if a variable is outside the radical. If there's a variable outside a radical and it's an even root, so our square roots, fourth roots, sixth roots, and going on, there's a high likelihood that we'll definitely need to check our solution. Don't always immediately throw out the negative, but there's a high likelihood the negative's not going to be it. There are some cases where the positive solution's not true, but the negative does work. Now, questions on that before we move on to this one here? So let's look at this one here. Square root of 3m plus 10 equals 1. There is one radical, so we need to get it by itself. So we would minus 10 from both sides, which will tell us that the square root of is equal to negative 9. This is indeed going to be no solution. Because again, we have a radical equal to a negative number. It doesn't work. This is no solution. Now, if we didn't notice that, we could still go through our process, square both sides, which will tell us that 3m is equal to 81. We divide both sides by 3, telling us m is 27. But if we check this, square root of 3 times 27 plus 10 is equal to 1. Both sides 1. But the 3 times 27 would be 81. Square root of 81 is 9. And when we add it to 10, we get 19. That's not true, so m cannot be 27. Questions on this here? Kind of makes sense so far? Now, I can show you this graphically. Negative 9, graph. That's the nice thing about the graphing calculator. It'll graph the line negative 9. So we're saying the square root of 3m equals negative 9, yes? So that graph we need to intersect this line right here. Y equals second square root 3. Instead of m, we'll use x. Does that blue line get anywhere close to the red line? No, and as we keep going out bigger and bigger numbers, it's getting farther and farther away. It seems like we could go to the left, but again, we can't take the square root of a negative number, so they don't get anywhere close to each other. Kind of unfortunate. But it does tell us that a square root, an even root, cannot equal a negative number. Questions on anything we've done so far? We ready for this one? Yes. So it does look a little different than the ones we've had before. We do have a variable outside the radical. Now, our first step, is there one radical? Well, yeah. If so, get it by itself. Is the radical by itself? Yeah. Step 2, put both sides to the nth power. What power are we putting both sides to? 2. Now the right-hand side's a little bit nicer because the radical and the square will cancel, telling us that this is 7p plus 15. The left-hand side is not going to be p squared plus 1. I mean, it will have p squared and it will have 1, but it's not just going to be that. Because any time we square something, we're multiplying it by itself. So whenever we have two terms with a addition sign or subtraction sign, one of our addition or subtraction signs in the middle, we are going to have to multiply by itself. Now, if it had just been 1p, we could have squared it and got p squared. Because here, p plus 1, we're going to have to distribute. Our p times p is p squared. P times 1 is plus p. 1 times p is plus p. And lastly, 1 times 1 is plus. So as I said, we will have p squared and we will have 1, but that's not all. We have plus 2p because our middle term. So we have p squared plus 2p plus 1 is equal to 7p plus 15. So we just have to be careful with our middle term. If we just squared those two terms inside the parentheses, we would have lost the middle term, which would have changed this answer completely. Are there any radicals left? Well, no, right? So we need to solve. And we need to get what? This equal to? So the first thing we can do is what? Huh? We could. I would go the other way. Because if we minus 2p, it would mean we'd also need to minus 1 and minus p squared. We'd move 3 things. But if we subtract the 7p, and then we would minus the 15, gives us p squared minus 5p minus 14 is equal to 0. Because here there was 3 on one side, 2 on the other. It only takes me 2 moves to get those to the one side. It would take me 3 to get to the other. Does that make sense? Yeah. And since we're graphing it, x squared minus 5x minus 14. It really doesn't matter how it looks. We'll end up moving it whichever way is easiest to get everything on the same side. We do have one positive and one negative case. Yes, indeed, negative 2 and 7. So again, variable outside we need to check. Negative 2 plus 1 is negative 1. Now the other side, we can type this in a calculator. 7 times negative 2 plus 15 is 1. Well, negative 1 is indeed not equal to 1. So p equals negative 2 does not work. Now we can check the other case. 7. 7 plus 1 is 8. Eight does indeed equal 8, so our one solution is that p is equal to 7. Questions on this here? Questions on anything we've done so far? We'll finish this tomorrow.